Hello dear students. So welcome to the structure of atoms, assertion and reasons. Well, this is going to be our last video for the chapter structure of atoms, right? So in assertion and reasons, these kind of questions are usually expected in your JEE main examinations. Okay, wherein we will be given one particular statement which can be a fact and it is going to be related to a relevant topic. So that particular statement is a statement which is not fixed. It can be true, it can be false. Okay, and for that statement, in order to aid to that statement, what we have is a reason. So now the reason can be the explanation to the first statement. The reason can be a supporting explanation, it can be true or it can be false. So you need to understand the statement given. You need to observe the two statements, that is the assertion and the reason, and then we will conclude it by ticking it on one of the options. So usually what happens is you are going to get options such as, okay, if you observe the first option A says that if both assertion and reason are true and the reason is the correct explanation for the assertion given. Okay, so this is one possibility. Second possibility is that if both the statements are correct, that is the assertion and the reason, both of them are correct, and the reason works as a correct explanation for the assertion. Okay, so in that condition, we are going to say B. Okay, moving forward with the third one, what it says, if assertion is correct, that is it's true, but the reason is false. Okay. D, if assertion and reason both of them are false. Last one, if assertion is false but the reason is correct. Okay, now let's observe one by one the following questions. So, first question says that assertion, Thomson's atomic model is known as the Rasin pudding model. The reason is the atom is being visualized as a pudding of positively charged with electrons, that is the reasons embedded in it. Yes. Now, whenever we were speaking about the Thomson's atomic model, what we understood from that particular model was, he considers the atom as positively charged sphere. He says that the atom is a positively charged sphere, right? So, this particular positively charged sphere had negative charged electrons which were embedded inside it. So, he says that the electrons were embedded inside. Okay, just like the raisins which are embedded inside the pudding. So, therefore, he says that these are the negatively charged particles which are embedded inside. Yes. Now, assertion is that Thomson's atomic model is also regarded as the Rasin pudding model. Yes, we do agree with that. Reason is also correct, that is the atom is visualized as a pudding of the positive charge with the negative electrons embedded inside it. Yes, this is perfect. So, if you go forward, if you just go for those particular options given, what we have, A, if both assertion and reason are true, and the reason is a correct explanation for the assertion. Yes, in this particular case, in this particular question, as what we have, that is the option A. So here we have the option A for this particular case. Okay, so option A for the question number 1. Let's go with the second question. So, second question says that the transition of electrons from N3 to N2 in hydrogen atom will emit greater energy than N4 to N3. Okay, this is one statement. Second one, N3 and N2 are closer to the nucleus than N4. Yes. Now, if we observe here, the assertion in this particular case, what it says, if we understand this by the help of a figure. Okay, let's say this is N equals to 4. N equals to 3, N equals to 2, N equals to 1. Okay, these are the different energy levels. Now, they are speaking with respect to the transition of electron from N3 to N2. Alright, they are speaking about the transition of electron from N3 to N2. This is the first transition. Okay, this is that this particular transition is going to emit whatever the energy is going to be emitted. This energy is higher when we compare to the energy that has been emitted because of the transition from N4 to N3. That means when we compare to this transition, the energy of this particular transition is higher. Yes, that is correct. What is the second one? What it says? N3 and N2 are closer to the nucleus than N4. Now, in this particular scenario, if we consider that this is a nucleus, let's say this is shell number 1, 2, 3, 4. Let's say we have the 4 shells. Now, N equals to 1, N equals to 2, N equals to 3, and finally N is equal to 4. Okay, fine. Now, if you observe, yes, N3 and N2 are closer to the nucleus when compared to that of N4. Perfect. Even the reason over here is correct. But does our reason over here in this particular question serves the perfect example or the explanation to the assertion? It's not. So in this particular case, what we can say is both assertion and reason, both of them are correct. But the reason is not the correct explanation for the given assertion. Right? So if we go back, what we have here, we are going to say that if both, that is, if both assertion and reason are true, but the reason is not the correct explanation for the assertion. Right? So therefore, for the question number 2, okay, the answer is B. Going forward with question number 3. Assertion. Absorption spectra consists of some bright lines separated by dark spaces. Emission spectra consists of dark lines. Okay. Now, we need to understand this before direct. So here, first, whenever there is a white light, okay, this is a light radiation, let's say. Now, whenever there is a white light and that passes through a substance in such a way that the substance has a capacity to absorb certain wavelength from the light. Okay, so let's say there is a simple plastic over here, a red color plastic that has been kept here. Okay, so this is a body over here which is going to absorb few radiations from the light. Okay, it is going to absorb few wavelength from the light and then it emits the rest of them. Now, when you observe, when you analyze this particular radiation using a spectrograph here, we'll use a spectrograph and we'll analyze about this radiation. And when we analyze that radiation, what we see is whatever the spectra we get here, this spectra, which was actually a continuous spectra because it's of the white light, but because of the body which has a capacity, which has a tendency to absorb certain wavelength, here certain lines are missing. Here certain lines will be missing in this case. Okay, but what this thing says is absorption spectra consists of some bright lines separated by dark spaces. Okay, here there are going to be some dark lines. Correct. So, what is the reason? Reason says that the emission spectra consists of dark lines. No. Now here, whenever there is a body, let's say there is a body and this particular body has a tendency to emit radiations. These radiations which are being emitted, let's say these are the radiations which are being emitted and these are analyzed. Okay. Now when we analyze using a spectrograph, we get a spectrum. So in the spectrum, what will happen is there is a discontinuous spectra with several sharp dark lines. There are continuously dark lines. So when we observe the different types of options given to us, okay, what will happen is that in that particular case, both the assertion and the reason are false for that. Okay, because both of them are not matching to the explanation. So therefore, if you observe, both of them are wrong. Okay, so for the question number 3, what we have the answer is as B, right? 2 electrons in an atom can have the same values for 4 quantum numbers. Assertion. Reason. 2 electrons in an atom can be present in the same shell and orbital and have the same spin. Now, perfectly wrong answer here. Both of them are wrong because both of the statements are going against the Pauli's exclusion principle. So, according to the Pauli's exclusion principle, what it says is an electron, okay, a particular electron in an atom cannot have the same set of 4 quantum numbers. That is, the 4 quantum numbers N, L, M and S. At least if there are 2 electrons, okay, if there are 2 electrons, both the electrons can have the same shell number, okay, same subshell, same orbitals, but at least these can be correct values. These particular values can be same. But at the end, where it differs with respect to the spin of the electron. So therefore, according to the Pauli's rule, no 2 electrons in an atom can have the same values for the 4 quantum numbers. So therefore, the assertion is wrong. Reason, 2 electrons in the same atom can be present in the same shell and same orbital and can have same spin. Perfectly wrong answer here again. So therefore, both assertion and the reason, both of them are wrong. So in such scenario, we can say that for this, we can choose the option as B. So option B says that if assertion and reason, both of them are false. So for the question number 4, option remains as B. Moving forward with the question number 5. Assertion. Cathode rays are a stream of alpha particles. Okay. Reason, they are generated under high pressure and high voltage. Yes. Now, cathode rays. Discharge tube experiment. So, in a discharge tube experiment, what we knew was the rays which were occurring, or the rays which were produced from the cathode section, right? So now if we observe the discharge tube experiment, okay, so there the radiations which were obtained from the cathode side were known as cathode rays. They were negatively charged particles. Okay, almost like an electrons, or you can call them as electronic species itself. While alpha particles are actually doubly ionized helium particles. So therefore, we cannot say that the cathode rays are positively charged. Cathode rays are negatively charged particles which occur from the cathode side in the discharge tube. Right? So assertion is not correct over here. When we observe to the next one, that is the reason. What it says? They are generated under high pressure. They are using the term as a high pressure in this case. Okay. Now, high pressure, but when we observe the discharge tube, we had a vacuum pump section, right, through which we reduce the pressure. So therefore, this particular option is wrong. Okay, while if you observe high voltage, yes, it is correct, but because of the high pressure, our reason becomes wrong. So therefore, again, assertion was already wrong answer and reason is also wrong. So therefore, for this particular scenario, option becomes as B. right? So let's move to the next question now. Okay, coming to question number 6. Among these, which one represents the S block element? Now, in an S block element, the element in which the last electron enters into the S orbitals or the S subshell. Okay, so there are two possibilities. So S block elements, there are two types. You already know one. That is 1A and 2A, right? So now in 1A, the electron configuration is S1. That is, only one electron is there in the outermost shell. Okay, so, and if we are speaking about 2A, the outermost shell is completely filled with the 2 electrons. Now, let's observe the given condition. Now, N represents the shell, L represents the subshells. So, we already know that the electron is going to enter into the S subshell, right, or the S orbital. So, therefore, if we observe the two values given here, L is equal to 0, L is equal to 0, yes, these are correct. But if you observe L is equal to 1, azimuthal quantum number L is equal to 1 is for the P block elements, right? So therefore, as this is for the P block element, of course, this particular option goes off. Okay, so now the option over here, observe N2, N is equal to 4, correct? S block, or you can say as an S orbital, both of them have plus half. Okay, so the option is both, that is A and B, right? So therefore, there are certain questions where you can see that both the options may be correct. In case if they do not give you like this, then you should be able to justify for that answer. Okay, so in case if we have a particular question wherein there are two answers which are actually correct. Okay, so in such condition, if you just mark one particular option, you will be awarded partial marks. Okay, partial marks in a sense, out of 4 you will be given just 2 marks. Now, in case if you select one correct and you select another one which is wrong, you will lose completely. You will lose all the marks over there. Okay, now if you select both of them, yes, you will be awarded complete 4 marks per question. Okay, so you need to observe every single option, then come to a conclusion, right? So going forward with the next question. So final one, we have to match the following type of question over here. So orbital angular momentum of electron. So here, if we observe orbital angular momentum of electron in a hydrogen like atomic orbital. So here, if we observe all these particular things, A, azimuthal quantum number. Okay, so I will write over here A goes to Q, right? Next one. A hydrogen like one electron wave function obeying the Pauli's exclusion principle. Please make a correction over here. It should be B, C, and D. Okay, fine. So B. So a hydrogen like one electron wave function obeying the Pauli's exclusion principle. So P. Electron spin quantum number. So B goes to S, right? C, shape, size and orientation, of course. Principal quantum number, so C is for principal quantum number, that is P. D, probability density of electron at the nucleus in hydrogen like atom. So in this case, there are two options, 1, 2, right? So I will go with, so finally for the option B, probability density of electron at the nucleus in hydrogen-like atom. So in this particular case, probability density, okay, for the probability density, it goes with the principal quantum number and azimuthal quantum number. So D, the answer is what we have is B and Q. So this is the correct sequence.